Hello, everybody. Welcome. Tonight, our guest is Dr. Thomas, I'm going to mispronounce this, I'm afraid, Weimbs.
Perfect.
PhD director of the Thomas Weimbs Laboratory, University of California, Santa Barbara, professor, PKD researcher at Santa Barbara Nutrients, and Ketogenic metabolic therapy pioneer. Dr. Weimbs received his doctorate degree from the Department of Biochemistry of the University of Cologne, Germany in 1993. He conducted his postdoctoral research at the Department of Anatomy, University of California until 1999. That same year, he joined the Department of Cell Biology in the Lerner Research Institute at the Cleveland Clinic as an assistant. He's a professor now, as an assistant professor, where he established his research laboratory focusing on investigating membrane trafficking, elliptical cell polarity, as well as molecular mechanism underlying polycystic kidney disease. In 2005, Dr. Weimbs was recruited to the Department of Molecular, Cellular, and Developmental Biology and moved his laboratory to the University of California, Santa Barbara. He is currently a full professor and a department vice chair in the MCDB Molecular, Cellular, and Developmental Biology Department. Research in the Weimbs laboratory is centered around certain special areas of investigation, focused on investigating autosomal dominant polycystic kidney disease, or ADPKD, considered to be the most common life-threatening monogenic inherited disease. ADPKD affects over 600,000 people in the U.S. alone and is the leading cause of kidney failure and leads to significant cardiovascular complications. Currently, no cure exists for this disease, and most patients require renal transplantation or lifelong dialysis for survival. Research in the Weimbs laboratory aims at understanding what leads to PKD disease progression and to test new strategies for therapy. The lab's research has led to the launching of a startup company out of UCSB Santa Barbara Nutrients, Inc., to translate research findings and make innovative products available to improve human health. Please give a warm welcome to Dr. Thomas Weimbs. Doc, how are you?
I'm great. Thank you, Jim. Thanks for having me. Appreciate it.
Did I get that last name right?
Yes, you did. The last time and the first time. Weimbs, exactly.
The one in the middle, not so much. Yeah. Okay. Did I state everything correctly in the introduction?
Yep. Yeah. Everything was great. Thank you.
Please tell us a little bit about where you grew up, your educational experience, and your current employment.
Sure. Yeah, I'm from Germany, hence the accent, which I don't seem to lose, and grew up in Germany, in Cologne, the city of Cologne. Got my undergrad there at the University of Cologne and my PhD in biochemistry. Then I moved to San Francisco to do postdoctoral research at UCSF. And after that, then, as you already mentioned, I started my first independent research lab, focusing on a bunch of things, but then eventually kind of pivoting into polycystic kidney disease, and for a number of good, interesting reasons. And it has kind of stuck. And we have done a lot of research on polycystic kidney disease over the last probably now 25 years-ish, around that. So, published a lot of papers, made discoveries, and we have most recently kind of started translating our research findings into the clinic. That's where the company comes in that we launched out of the university.
In 2005, I understand that you were recruited to the Department of Molecular, Cellular, and Developmental Group and moved your laboratory to the University of California, Santa Barbara, and you are currently a full professor in molecular, cellular, and developmental biology. Please tell us, what do you do there?
Yeah, so I'm a professor, which means I'm teaching, but because it's a research university, one of the top tier research universities in the country, of course, all the professors also do research. So I direct a research lab. My teaching is on things like pharmacology and cell biology and so on. And in my research lab, we solely focus on polycystic kidney disease. So like I said, we have done that for 25 years. So I have PhD grad students in the lab and postdoctoral researchers and undergrads and so on. So they all work on different individual projects on researching PKD. And there's a lot of collaboration going on, within the lab, between lab members, but also with other groups, in different places, nationally and internationally. So we have a lot of collaborative projects as well.
What is molecular, cellular, and developmental biology?
Yeah, it's essentially a fancy name for our department, kind of reflecting the fact that the faculty in our department are very diverse in their interests. So we have people that are more on the molecular side, some are more on the cellular side, some are more on the big picture developmental side, and actually lots of other things as well. So it's just sort of a catch-all name. So you could also call it, I don't know, or if you call it biology, that's maybe too broad. So it's more on the, kind of just a fancy name. Yeah.
How does this help you in the study of polycystic kidney disease?
Yeah, so polycystic kidney disease, as you well know, is a genetic disease, but it's a form of chronic kidney disease, or CKD, but it has a genetic component, right? So the underlying cause is, somebody inherits a mutated gene from one of their parents, and they're on a trajectory to get chronic kidney disease. So, many people, many labs and researchers have studied the underlying mechanisms, what actually leads to polycystic kidney disease. We do know the mutated genes, but we don't really know what the genes are good for, if you will. And what are the different molecular pathways that are between the gene mutation and what ends up being a polycystic kidney at the end, right? So it's important to understand that so that we can then try to intervene and do something about it and come up with a therapy. So that's kind of the idea, right? So it's very hard to try to improve a disease, if you have no idea what's going on mechanistically there. So that's usually the first thing. And I would say literally the first, few decades of PKD research were really spent on trying to identify all these different mechanisms that are involved. The problem is that there's so many mechanisms, like hundreds and hundreds and probably thousands of things are all changed in polycystic kidneys, that it has been very difficult to say, hey, it's this one thing. If we just fix this one thing, we can cure the disease. So that hasn't happened. There's not just one thing, except maybe what we have been doing, but where our research has led us to, and we can go into all that.
I understand that research in the Weimbs laboratory is primarily focused on a special emphasis with autosomal dominant polycystic kidney disease, or ADPKD. Why is ADPKD considered to be the most common life-threatening inherited disease?
Yeah, so it's a very common disease. It affects about 600,000 people in the US alone. It's still a small percentage of chronic kidney disease in general. And you may be surprised that chronic kidney disease is actually essentially the most common non-communicable disease out there. It's more common than cancer, more common than cardiovascular diseases, more common than type 2 diabetes, for example. So in the US, 14% of the population have chronic kidney disease. So it's a huge number. And out of this very large number, a smaller percentage, between 1 and 2% have polycystic kidney disease. But, a small percent of a big number is still a big number. So that's why lots of people have polycystic kidney disease. And it's considered maybe the most common life-threatening disease of this kind out there.
12.5 million people worldwide are affected by PKD?
Right. Yes.
Please describe for us the possible significant cardiovascular complications that accompany ADPKD.
Sure. Yeah. So, like the name says, polycystic kidney disease is primarily known for the kidney effects. The kidneys get big, they grow very large, they become highly cystic and fibrotic. And eventually patients lose their kidney function. That means they have to be on dialysis and hope to get a kidney transplantation. But in addition to the kidney disease, people with PKD also have extra-renal manifestations of the disease. So things outside of the kidney can be affected. And that includes cardiovascular complications. So one very common symptom of polycystic kidney disease is hypertension, so high blood pressure, which is chronic in the disease and even starts very early on. And as you know, hypertension by itself can already cause cardiovascular problems, so things like stroke, for example. And patients with polycystic kidney disease also have an elevated risk of what's called intracranial aneurysms. So blood vessels in the brain can essentially pop, which is a form of stroke, and that can be deadly. So it can be very dangerous. Luckily, it's not extremely common in polycystic kidney disease, but it is more common than in the general population. So those are some of the cardiovascular complications of the disease.
I have read that there is no cure for PKD. Are you familiar with any steps that are currently being taken to find a cure for PKD? And if so, can you please describe them briefly for us?
Yeah, sure. So first of all, what is a cure, right? So there are some diseases that actually have cures, where essentially you walk away free of the disease. That will probably never happen in polycystic kidney disease. I don't think there will ever be a cure, at least not in our lifetimes and maybe our children's lifetimes. And that's just due to the nature of the disease. However, that doesn't mean that there isn't hope, because essentially, the biggest problem of polycystic kidney disease is the loss of kidney function. And, a patient needs dialysis and a kidney transplant. If you can slow the progression of the kidney disease, or maybe stop it, maybe even reverse it partially, you can end up dying of very old age with normal kidney function, right? And that's the goal, right? So we want everyone to die, but we want them to die of old age and still having, happy kidneys. So that would mean mission accomplished. It's not technically a cure, but it probably comes pretty close. So unfortunately, there's currently no medication that can do that. So there are no drugs that can stop the progression of polycystic kidney disease, let alone reverse anything. However, that is something we have been working on with our approaches, and what we have, and we can go into all the details, what of the nutritional therapies that we have come up with. They have in animal models, we have mice and rats with polycystic kidney disease. We can actually reverse the disease, which is otherwise unheard of. So there's no drugs that can do that. And we have even done clinical studies where we see essentially the same result. We see improvement of kidney function with this type of intervention. So I would say it is possible to at least very significantly slow the progression of the disease, maybe halt the progression of the disease, stop it, and maybe even partially reverse it. That's probably not possible currently with any medication, but with these nutritional interventions we can talk about, that's exactly what we have seen.
I was just going to ask you about that. Can you describe for us the current options, or as you're calling them, traditional interventions to help with the survival that actually do exist for PKD patients?
Sure, yeah. So most patients with PKD, they are essentially managed, with for symptoms. Things like the high blood pressure is managed with antihypertensive medications, and pain and so on is managed with pain medications. But none of that really, stops the progression of the disease, because those are not addressing root causes of the disease, the actual cause of the disease. There's one approved medication that's a drug called tolvaptan, and the brand name is Generic or Genarq, depending on how you pronounce it. That is the only one that's currently out there. It also does not stop the progression of the disease. It only slows it by a certain degree. That's pretty much what's out there, right? So you can manage the symptoms. You can use this one drug that slows the progression of the disease. Maybe not in every single patient, and not every patient qualifies for the drug. There are strict exclusion criteria. It's also very expensive. The drug costs about, say $200,000 per patient per year. Which means if someone has a really generous health insurance, they can maybe get it. If not, maybe they can't. And of course, people with the disease, you mentioned, over 12 million worldwide. There are many, many countries that are not as rich as the US, where people don't have access to this kind of drug anyway.
Okay. I understand that the Weimbs laboratory aims to understand what leads to PKD, the disease progression, and possibly new strategies for therapy. Can you please explain those processes to us and where your work stands currently without waiving confidentiality?
Oh, yeah, sure. So, over the 25 years we've been doing this, we have focused on trying to find the next new drug target, that we could then develop a drug on, like pretty much everybody else has been doing in the PKD research field. Until about 10 years-ish ago or so, we kind of stumbled on some research results that were very surprising. And with a lot of additional research and following up, we kind of nailed down the mechanisms and found that polycystic kidney disease is actually can be accelerated, right? So everybody starts with a gene mutation to begin with, but just having the mutated gene alone does not necessarily lead to full-blown polycystic kidney disease. There needs to be a trigger that also triggers the disease. And you might have heard the the old saying that genes load the gun, but lifestyle pulls the trigger. So some people have heard it, right? So everybody has a few bad genes, and obviously someone with polycystic kidney disease definitely has a bad gene that kind of loads the gun, but you still need a trigger to then trigger the gun and start the disease process. We found that some of the triggers are essentially controlled by our diet and lifestyle, in the industrialized society. As you know, we people in America and many other countries, we eat, for example, completely different foods than our ancestors did, right? So back in the Stone Age, we didn't eat muffins and donuts, and we didn't eat rice and grains and anything that's an agricultural product. We ate, we developed as hunter-gatherers back in the day, which means our ancestors primarily ate animal products. Like they were hunting bison and mammoths, so they were essentially carnivores, depending on what region in the world they lived in, and maybe they had a lot of fish if they were by the sea. But there was no agriculture, right? So you didn't have grains, you didn't have essentially fruit, hardly any vegetables, that kind of thing. So our diet and lifestyle has very radically changed, and that is a very recent change. So the agricultural revolution, that is when agriculture was invented by humans, and that was only 12,000 years ago. So that's a very recent thing. Our genes evolved over the last 1 million or 2 million years ago. Right? So much, much longer. And they were optimized for a more of a carnivorous lifestyle. And that also means that our ancestors spent, probably half of their lives in what's called ketosis. So what is ketosis? Ketosis is a natural physiological state that we can go in and out of, depending on how much we eat, right? So if we eat breakfast, lunch, and dinner, and snacks in between, we're not in ketosis, when we're never in ketosis. Because our body essentially is forced to run on blood sugar. That's the main fuel. However, if we stop eating altogether, or if we stop eating carbohydrates, meaning sugars and starches, our body then can switch and start burning fat. Right, and that's what's called ketosis. So the fat gets burned, and some of the fat gets converted into what's called ketones. And the ketones are then the fuel that our body runs on instead of the blood sugar. And our ancestors would have been in and out of ketosis, very, very frequently. But today, in our westernized societies, we're not. We just don't experience ketosis anymore. And that's something important we have discovered, is that the state of ketosis is highly protective for kidneys, including polycystic kidneys. So if we take a mouse with polycystic kidney disease and we put it on something called a ketogenic diet, so that kind of forces the mouse to be burning fat, it protects the kidneys, and it stops the progression of the polycystic kidney disease. We've even found that it can partially reverse the polycystic kidney disease. So kidneys can shrink in animals, and cysts can shrink. Kidney function can be regained. And we have done this in mice and in rats, also in cats with polycystic kidney disease. So they are one of our collaborators has cats that have polycystic kidney disease, so we can treat them just as well. It works in all of these models. And we have even done clinical studies in people with polycystic kidney disease. So those are already published, and more are to come and are in the pipeline. And happy to talk about all that as well. I don't want to go into a monologue. I rather let you ask some questions.
Don't worry, Doc. I'm going to ask about it. It's coming. Let's talk about the Santa Barbara nutrients, the SBN. Concerning the SBN, I understand that you are the president and chief scientific officer. Can you tell us what your duties and responsibilities are with the SBN?
Yeah, sure. Yeah, so we launched this company just a few years ago, essentially during the COVID break, if you can call it a break. The rationale for launching the company is that we had found in my lab at the university that this ketone beta-hydroxybutyrate, so there's, maybe I should back up for a second, right? So you can put people or animals into ketosis by dietary changes. You restrict carbohydrates in the diet and you can induce ketosis. You can also just drink the ketones or feed somebody the ketones. And the main ketone is called beta-hydroxybutyrate. We just call it BHB. It's easier to say. And that's a very simple substance that you can already buy as a supplement, anywhere you want. So it's widely available, widely used, and fairly inexpensive. At the same time, we had also discovered that citric acid is highly protective in polycystic kidney disease for completely different mechanism. And I'm sure you know citric acid, that is something you can buy in any grocery store. People bake with it and, you can use it for all kinds of things. You can, obviously eat it and it's a food. And citric acid is also very cheap, inexpensive, and widely available. And what we then found is that if you combine beta-hydroxybutyrate or BHB together with citrate and you start treating PKD with it, you end up with a synergistic effect. So they become even more potent. They kind of reinforce each other. So the good news is that two very simple, very widely available and safe supplements are very effective in polycystic kidney disease, and they're very cheap. The bad news is that two widely available and cheap ingredients are effective in PKD. And the reason why it's bad is that no pharmaceutical company would take it from there. Right? So there's no financial incentive to develop a drug based on that because you cannot take a cheap compound that anyone can buy anyway and invest $1 billion, and turn it into a drug and hope to get your investment back. But that's not going to happen with a very cheap a drug like that. So I became convinced that we could just simply publish our papers and move on from there and do something else, and the whole thing will die right there. Or we could do something about it. So I essentially decided I want to do something about it. This is so effective. I don't want to just throw it in the trash can in the form of an academic paper, if you will, but do something about it. So I got together with a group of highly motivated folks. Many of them actually have polycystic kidney disease. Many are industry experts, and we essentially said, let's launch this company. Let's come up with a product, containing those two key ingredients, BHB and citric acid. Luckily, we were able to get a patent for the university on this whole idea of using this combination. So that allowed us to raise funds, launch a company. So it's essentially a startup company out of the university. We've created a product that is called Keto Citra. It's actually not a supplement, but a medical food. So it's neither a drug nor a supplement nor a food. It's a medical food. And almost nobody has ever heard of medical foods before. Medical food is an FDA regulated category that is just different from drugs and supplements. And as you know, the Food and Drug Administration, with the FDA, regulates, obviously foods and drugs, as well as, supplements and ordinary foods and medical devices and so on. There's one more category called medical foods. So we're able to classify our product as a medical food, which has some advantages, and it makes it kind of clear what it's for. So it has been on the market for, I want to say 4 years now. And lots of people with polycystic kidney disease have been taking it, are taking it, and I would say have had really good success in many cases. And obviously we're doing clinical studies to quantify the outcomes. And I can tell you all about that as well.
What are the benefits of Keto Citra?
Yeah, so it's essentially mimics this physiological state of ketosis that I mentioned, right? So instead of having to be on a very, very strict ketogenic diet, which is difficult for people to adhere to long term, you can essentially take a shortcut and take Keto Citra and essentially drink the ketones instead of having to forcing your body to produce it yourself. So that's one advantage. So you can get away with maybe less of a strict clean diet. The other advantage is the citric acid, and that's formulated in a way that it is kidney protective, and it helps to alkalinize the urine pH, or I should say to normalize the urine pH. So essentially the acidity of the urine that is well known to be too acidic most of the time in people with polycystic kidney disease, and that is detrimental for the and kind of worsens the progression of polycystic kidney disease if somebody has a very acidic urine. So that's something that Keto Citra can help to normalize as well. It can also help to neutralize what's called oxalate, and we're probably getting too much into the technical weeds, but oxalate is a plant poison, if you will, that occurs in many plant foods, like spinach and many nuts and so on. They have a lot of oxalate in them, and it can impact the kidneys and essentially damage the kidneys and worsen the progression of polycystic kidney disease. So that's something that can be neutralized with Keto Citra. So it's kind of a clever formulation that actually addresses several different renal stressors, if you will, at the same time.
I also understand that you have created a nutrition and lifestyle program for PKD called, and I don't know if I'm going to pronounce this correctly, Renew.org. What is that, and how does one become involved in the program? Mm-hmm. And there's the link to the program also in the ticker.
Awesome. So we just pronounce it Renew, like it rhymes with you renew your kidneys, if you will. And it also stands for renal nutrition. So that's kind of how we can remember what it means, but renew renal nutrition. It's an online, so completely 100% remote nutrition and lifestyle program where anyone can sign up. Anyone with polycystic kidney disease can sign up for it. It's essentially a 3-month, pretty intensive program. So it's 3 months plus a 1-month onboarding period. So the whole thing, start to finish, takes about 4 months. So it's maybe similar to, I would say, to a college class, right? And as you know, I'm a college professor. I teach college classes. We actually on a quarter system, so our classes are also 3 months long. So it's very similar. So it's essentially a college class. Obviously you have to pay tuition for college classes, and you pay tuition for the Renew program. because they are very dedicated professionals running it. We have a director of nutrition, Kathy Jensen is her name. She's a registered dietitian, very, very, very experienced, especially with ketogenic metabolic therapy and kidney disease. We have a scientific director, Melina Messing. She's a PhD level scientist and kind of is in charge of making sure this whole program is scientifically oriented and we can measure the outcomes of the program, the participants in the program, and publish papers on it. And Melina actually has polycystic kidney disease herself, so she has the personal experience and also the personal motivation behind it. We have a medical director, Dr. Sharon Turbin, who's a PKD expert from Johns Hopkins University, which is amazing to have someone of that caliber on the team. And then we have, many other folks. We have a clinical research director who works hand in hand with the whole team and kind of integrating the Renew program into clinical trials. So we're testing it in clinical trials. And those trials are actually not done by us per se. They are done by independent academic investigators in top universities. So they run the trials, we just support the trials, but they're independently done. And whatever the outcome is the outcome, and they will publish it, good or bad. So we'll find out.
What are the benefits of the Renew program?
Yeah, so let me put it this way. So our medical food, Keto Citra, is essentially just a powder. You scoop it into a glass of water, you drink it. However, I never want to give people a free pass, right? I don't want to ever let people think all they have to do is drink this magic powder and they're good to go and they can eat any junk foods they want. That I think is not a good idea, to let people believe that now they're immune to everything, because that's never the case. So I always highly recommend to start with Keto Citra, but then also clean up the diet, right? So try to clean up renal stressors that can worsen polycystic kidney disease, things like oxalate, things like phosphate, things like things that increase uric acid in the blood, for example, sugar. Obviously, sugar, starch, anything that causes high blood sugar values and high insulin levels and causes, high blood pressure and so on. So that's why we've created this Renew program that is really built around Keto Citra and is meant to reinforce Keto Citra with nutrition and lifestyle changes. And because the hardest thing to ever do is change your nutrition and lifestyle, most people kind of give up, right? So if a doctor tells a patient, I want you to lose weight by eating less and exercising more, right? I think we all know that this never works, right? Maybe out of 100 patients, maybe one can do it, lose weight by just being told, eat less and exercise more, right? 99 of the patients, they can't do it. They fall off the wagon. And the reason is, if a doctor just says that to a patient in a 10-minute doctor's appointment, that is not enough, right? So you cannot explain how to actually implement something like this in a 10-minute appointment, not even in a 1-hour appointment, right? So you need really detailed guidance and you need a smart system. So in the Renew program, the participants actually measure their own health parameters, right? So you do a finger prick at home, you measure your own blood sugar level, and you measure your own ketone level, and you measure your urine pH, and you measure your blood pressure and your body weight. So you can get instant feedback, if what you're doing is actually working. We also track your nutrient intake using a like a smartphone app, so everyone can keep track of what they're actually eating, and that's very different from what you think you're eating, versus what you're actually eating. So people get feedback and they get meetings, with the dietitian to keep them on track. We have weekly, we call them office hours, where the participants essentially Zoom in and meet with the dietitian and ask questions. Hey, this is a challenge for me. What do I do? And the office hours are essentially also for peer support. So everybody Zooms into the office hour, people help each other out. Somebody might say, oh, I had the same problem when ordering foods in the restaurant, here's what I did, that's the kind of food I'm ordering. And so lots of people kind of help each other out. It's the dietitian can chime in. And I think that is really what it takes to have a sustainable change in nutrition and lifestyle. So that's very different from a 10-minute doctor's appointment that just says, eat less and exercise more.
I have been told that SBN is heavily involved in clinical trials. Can you please give us a couple of examples of clinical trials that you are involved in to the extent that you can, and tell us as PKD patients why they are important?
Mm-hmm. Yeah, no, great question. Yeah, so it's all out in the open and transparent. We don't do secret trials or anything like that. So why even do a clinical trial, right? So I would say that is not a common thing. But so a typical dietitian out there, just treats patients, and a typical doctor just treats patients, but they don't actually do a clinical trial to keep track of the outcomes. We just think it is very important to see this from a scientific perspective, quantify outcomes so that we can, number one, convince the world about the outcomes, but number two, also improve things, where maybe we can learn something and tweak something. So a clinical trial essentially means, you put a group of people with polycystic kidney disease on the intervention. In this case, Keto Citra with the Renew program. And then you have a control group, so people that are not on the intervention. And that's what we're doing in Japan right now. There's a trial that is already in full swing, already over a year has been going on. The final enrollment goal is 200 patients, split into an intervention group of 100 versus a control group of 100. Everybody gets Keto Citra. Everybody gets the nutritional and lifestyle changes, and they learn it through the Renew program, the Japanese version of the Renew program. And then people are monitored for a whole year. Right, so it's a 1-year follow-up. We already have some interim results, which look amazing. So we're putting together a publication right now on just an interim analysis. So essentially 3-month outcomes, of a good number of patients that have already gone through the program. But because it's a 1-year study and a very large study, it will take a couple more years until everything is said and done. So we will only have the final results in 2+ years from now. But I'm hoping we can do an interim analysis, which has already been presented at a recent PKD conference, and we're actually presenting it again at an upcoming conference in November, kidney conference here in the US. Another trial we're doing here in the US with the Cleveland Clinic. So incidentally, I happen to get my start as an assistant professor at the Cleveland Clinic. So I was there for 6 years, I want to say. I know the person who is now the deputy chief of nephrology, still from the time there. And we've planned this trial, and we're actually launching it very, very soon. And same idea, right? So you put people on Keto Citra, you put them into the Renew program, and you measure the outcomes. In this particular trial at the Cleveland Clinic, we primarily focus on metabolic outcomes, which you can measure fast. Within 3 months, you can already see metabolic improvements. And people that go through the Renew program typically see stabilization of their blood sugar levels. They see often improvement in the kidney function, in the eGFR number actually goes up. They see improvement in pain levels. And as you probably know, people with PKD very often have pain. So there can be kidney pain. There can be other kinds of pain, including like migraines, and can be very common. And across the board, we have seen a significant improvement in pain levels when people go through the Renew program and use Keto Citra. We've also seen improvement in high blood pressure. So many patients are able to lower their blood pressure medications or even get completely off of it. But that's something we want to test in those clinical trials, essentially by independent academic investigators. So they're running the trial. They crunch the numbers, they do the statistics, they find out what the outcomes are.
Okay. I would like to ask you about what must be your central and most recognized study, your study on the keto diet and PKD, the beneficial effects of ketogenic metabolic therapy and polycystic kidney disease. Can you tell us how this study began? What were the findings? Does the study continue? And what results do you hope to obtain in the future?
Yeah, so this study we published in 2019, at the end of 2019. So it's now, 5-6 years ago. And that was really, I would say, a landmark paper that we almost stumbled on by accident, doing the animal type of research that we're doing in the lab. And it literally started as an accident, almost when a student in my lab decided to feed his mice with PKD less food, for a number of reasons. And he didn't actually ask me to do it; he just did it. I wouldn't have thought this would work, would have any benefit. So luckily, he didn't ask me; he just did it. And what he found, to my great surprise, is that the mice with reduced food intake had a very dramatic benefit in their polycystic kidney disease progression. So essentially, their kidneys did not progress. And then, we published the paper and tried then to understand afterwards what the mechanism is. And with much more research, then we figured out that it's actually this state of ketosis that is important, and in particular, the ketone beta hydroxybutyrate, or BHB, is important. So that's something that we published in this 2019 paper, and that was essentially the foundation for launching the company, but also launching, a lot of research in the lab to better understand the mechanisms that are involved. So now I have many busy and motivated researchers in the lab. They're looking at different aspects of those mechanisms. We're trying to see what BHB does to the immune system, to inflammation in the kidney, for example. That's an important topic. And BHB can act as a hormone. So there's a receptor, a BHB receptor, that we have genetic tools to get rid of the receptor in mice. So we can study whether BHB is still effective in that case, and which of the effects are receptor dependent and which ones are receptor independent. So a lot of things like that. So lots of mechanistic studies are going on.
Great. Do you have any final statements that you would like to make to our audience before we conclude the broadcast for the evening?
Yeah, sure. I would say chances are extremely high. If somebody listening has kidney disease and, especially maybe polycystic kidney disease, chances are very high that their kidney doctor is unaware of this research. And that is just how it goes. In medicine is usually, 20 something years behind the research. I don't know why, but that's how it is. Kidney doctors, or as any doctors, they're busy people. They're running around from one appointment to another. They don't have time to read the literature. So we just have to accept that. So oftentimes, I think it is actually up to the patient to find out what is going on at the forefront of the research and bring that information to their doctor. So I highly encourage everyone to look up our research. So everyone can go to my UCSB website, for example. All the papers that we published from my lab are posted there for free to download. So anyone can read them and anyone can print them out and bring them to their doctor. We also have a Facebook group. If you just put Weimbs Lab into Facebook, it's very easy to find. There are over 4,000 people with PKD are members of the Facebook group. Lots of good discussions. People tell each other about their own experiences. Using this way of this medication versus that supplement versus Keto, Citra, and so on. So I would say definitely join this Facebook group to just keep absorbing the information, learning more. Look up Santa Barbara Nutrients, our company. Try to learn all you can about Keto Citra and the Renew program. There's lots of information out there. Again, bring information to your doctor and tell them, hey, this is out here. What do you think? So I think that is an important step, that patients kind of advocate for themselves, because you can't wait 20 years for the doctors to catch up and start treating their patients with something that is already out there now. Because most people don't have 20 years, right? So the kidneys may not last 20 more years. And if anything, I would also say early intervention is very important, right? You don't want to wait until end-stage kidney disease and then do something about it. If you can intervene very early, where there's still kidney function to be saved, and you can have a much greater impact on health. So yeah, it's just, I would say everyone can do their own research, try to advocate for themselves. And we're not talking about drugs here, right? So Keto Citra is not a drug, a diet is not a drug. So these are not things that actually need, they don't need FDA approval or anything like that, right? So anyone can change their diet, today. That's not against the law to change your diet.
Great. Great job tonight on the broadcast, Doctor. I want people to know that this broadcast and the replay will be pinned to the top of my Facebook profile, Jim Myers, Myers. In the comments, I'm going to put a lot of the things that we talked about tonight, links, his articles, the diets that we spoke about, so that you can find them easily, and his website. So if you have questions you want to put to the doctor himself, you have that availability. And I just wanted to say, really great job tonight, Doc. Just fantastic amount of great information. And I wanted to thank you very much for coming on. Also, I've been sick quite a bit lately. I've been in the hospital 4 times since August the 1st, and doctor was kind enough to allow me to reschedule this broadcast so he could come on and educate all of us. And I want to thank you specifically for that. I have a couple of things I am going to button up with my audience. I'm going to let you go. I've kept you over 50 minutes. So I just want to say again, I appreciate you coming on and making us a little smarter tonight.
Thank you so much. Great questions, Jem. I really appreciate it. And, to shine a spotlight on what we've been doing. I greatly appreciate it.
Thanks, Doc.
Awesome.
All right. That's our broadcast for this evening. I will be preparing a replay, which I'm going to post to all of my platforms and all 120 of my groups and any keto group that I can find, including the doctors. So you should be able to find our replay out there someplace. Please like and share. We want to keep educating people that have polycystic kidney disease. So you have a good night, and we're going to end the broadcast. So take care, everybody. Thanks again, Don.
Thank you.